Hi students, welcome back to Smarter Everyday Over Learning. Dear students, in this session you are going to learn about a simple shortcut trick to find the bond order and the complete detailed information of bond order, the exact definition and different types of molecules and ions, how we can calculate the bond order also in this session you are going to learn. Okay, now let's see the definition of bond order according to Linus Pauling. He introduced first the bond order. Here the difference between the number of bonds and anti-bonds, this indicates the bond order indicates the number of difference between the number of bonds and anti-bonds. Here what about bonds and anti-bonds? Let's see now. The bonding molecular orbital denotes that shape of a molecule, exact shape of a molecule, and anti-bonding molecular orbital says that do not contribute the shape of a molecule, do not contribute to the detection and determination of the shape of a molecule. Okay, that's about bondings and anti-bondings, bonding molecules and anti-bonding molecules. Here the bond number itself, the number of electron pairs nothing but bonds between a pair of atoms, indicates that is about bond order. According to Lewis, in the Lewis representation of a molecule or an ion, the number of bonds present in between the two atoms is known as bond order. Number of bonds present in between the two atoms. Here is the atom, here is the atom. For suppose, according to this, number of bonds present in between these two atoms is known as bond order. Okay, for suppose a molecule, hydrogen molecule, just like this is the hydrogen atom and this is the hydrogen atom. Here this is known as H2 molecule. Here is the bond order is 1, and O2 molecule, here oxygen atom, and this is an oxygen atom, so O2 molecule bond order is 2. Nitrogen, just like this, nitrogen triple bond N, this bond order is 3. For suppose CO, carbon monoxide, the bond order is 3. Okay, for odd electron molecules, how we got these numbers? The simple trick, one formula, specific trick I'll tell you. Okay, now for odd electron molecules, as the 3 electron bond is considered as equivalent to half covalent bond. Bond order can be fractional also. Let's see the trick of this. For example, Lewis structure of NO is Lewis structure, nitrogen, single bond O, and lone pair of electrons, and here 3 electrons, here 1 single pair of electrons. Hence the bond order is, for these the bond order is 2.5. Okay, how I wrote just all these numbers 1, 2, 3 and 3 here 2.5. Let's see now. Trick to find bond order. Here you need to consider the total number of electrons in a molecule, and here is the bond order. For suppose the total number of electrons in a molecule, that number is 10. Here the continuation number you have to take 10, 11, 12, 13, 14, 15, 16, 17 up to 18 I have written here. Then what about the bond order? Starting from 1.0 you have to take. Here is 1.0, now 1.5, here 2, nothing but 2.0, 2.5, and here 3.0, again 2.5, now 2.0, 1.5, here 1.0. You need to remember this order, these numbers you should remember. Now students, examples, let's see one by one. For O2 molecule, you need to count the total number of electrons in this O2 molecule. Here one oxygen atom has 8 electrons plus another oxygen atom has 8 electrons, total 16 electrons. Here 16. So this O2 molecule, here we got the answer, the total number of electrons 16. So without any hesitation you can write the bond order here 2.0, nothing but 2. Okay, let's see the next example. Let's take an ion of O2 plus. Okay students, this we need to calculate the bond order. First of all, we need to calculate the total number of electrons for this ion. So as usual, same, oxygen atoms are 2, that is 16 electrons. Here plus 1 is there, so you need to remove 1 electron from that. So the number is 15. So 15 means here the answer 2.5. The bond order is 2.5. Okay, now O2 plus ion is more stable. If you say the magnetic character is paramagnetic in nature, this O2 plus ion. Let's see the next example. Here is the another one, O2 minus, only O2 minus. If I take, now you can calculate the total number of electrons. Again same like this. So 16 electrons, here minus charge is there, so you need to add plus 1. Now the number 17. 17 means the number is 1.5. So the bond order is 1.5 here for O2 minus. So this is still less stable. You can say the stability of this O2 minus, it is less stable, and this is also paramagnetic in nature. Now students, next example I am going to write here O2 2 minus. For this also you need to calculate the bond order. So first of all you need to count the total number of electrons. Here 16 electrons, here minus 2 is there, so you need to add 2 to this number. Now the number is 18. Now students, what is the bond order for this? Here 18 means 1.0, nothing but 1. So this is also has a least stability. If you say the magnetic in nature, magnetic character of this, diamagnetic in character. Okay, let's see number of examples. One more example. Here is the next trick for you for isoelectronic species. It's very interesting to observe that isoelectronic species have the same bond order. For these species, the bond order is same. You should remember this sentence. For isoelectronic species, the bond order is same. For example, here the first example, F2 and O2 2 minus. Here already for O2 2 minus we have calculated the total number of electrons. We got it 18. For F2, F means atomic number 9. Here F2, 2 atoms of fluorine is present, so F9. Here also the total number of electrons are 18. So each of them has the bond order 1. Why? Because here you can see, if the total number of electrons in a molecule is 18, the bond order is 1.0. Then 1 here. Now students, second example, N2 molecule and CO and NO plus. First of all, you need to count the total number of electrons here. For N2 molecule, here 2 nitrogens are presented, so 7 plus 7, there is 14 electrons. And for CO, carbon 6 plus oxygen is 8 electrons, now 14 electrons. And for NO, here is 7 electrons plus 8 electrons. Here plus 1 is there, nothing, no number is there, means you can assume that here is 1. So you need to subtract 1 from that. Now 14 electrons you should get here. Now students, for this is known as isoelectronic species. All are 14 electrons only. Now the bond order for this, here you can see if the number is 14, 3. The bond order is 3.0, nothing but 3. Okay, it's about the isoelectronic species. What we have, the same number of electrons, we should get the same bond order also. Here the most important point we have to remember, greater the bond order. If the bond order is high, then greater is the stability of the bond. Now obviously stability of the bond is also high. That is, greater is the bond enthalpy. Bond enthalpy also greater. Now the greater the bond order, shorter is the bond length. So bond order is inversely proportional to the bond length. Can remember these 2 points, very important. Okay students, now let's go for the next trick. Here for isoelectronic species also, how we can calculate the total number of basing upon the total number of electrons, the bond order we have studied now. Next students, if the compound has resonance structure, for suppose a compound has resonance structures, how to calculate the bond order? For this the main formula is total number of bonds in between the two atoms in all the resonance structures by the total number of resonating structures. Okay, here you need to observe the total number of bonds in between the two atoms. Okay students, let's see the examples. After that, total number of resonating structure, that molecule or that ion is having how many resonating structures also you need to identify. From those numbers you need to count the total bond order. For carbonate ion, CO3 2 minus. For carbonate ions, first of all let's see what are the resonance structures for this CO3 2 minus. Here is the carbon and double bond O, and here O minus, here O minus. So CO3 2 minus. And the next resonance structure is C double bond O. Here is O minus and here is O minus. So again you need to draw the next structure also. Here O minus, here is O minus, here double bond O. Okay, these are resonance structures of CO3 2 minus carbonate ion. Okay students, now you need to find out the bond order for this ion, means the total number of bonds in between the two atoms in all the resonance structures you need to identify. That means here one double bond plus single bond, here is one double bond plus single bond plus one single bond. Okay, total number of bonds you need to add by how many resonance structures this ion has? 1, 2, 3. 3 resonance structures. So here 2 double bonds plus 1 single bond plus 1 single bond by 3. So the number is 4 by 3 means 1.33. So the bond order of this carbonate ion is 1.33. Okay, let's see the next example. For nitrate ion NO3 minus. Okay, let's draw the resonance structures of this nitrate ion. Then only we can calculate the bond order. First of all, here is nitrogen, then single bond O, double bond O, here is the single bond O. Here students you need to denote the lone pair of electrons also. Here are 3 pair of electrons and here double bond is located, so only 2 pairs of electrons. Here only single bond, so students 1, 2, 3, 4, 5, 6, 3 pair of electrons with -1, negative charge. Okay, and again in another way, another resonance structure of this nitrate ion. Here is N, double bond O, single bond O, single bond O. Now if you represent the lone pair of electrons, here 2 electrons with 2 electrons only, and here only single bond means 1, 2, 3, 4, 5, 6, 3 pairs of electrons. Here with negative charge 1, 2, 3, 4, 5, 6, 3 pairs of electrons. Okay, now if you draw the next structure of this NO3 minus, here is nitrogen O, single bond O. Here if you place oxygen, now the pair of electrons can be 1, 2, 3, 4, 5, 6, 3 pairs of electrons. Here with a negative charge 3 4 5 6. Here double bond is located, so only 2 pairs of electrons. These are the resonance structures. Now you need to calculate the bond order for this. Now students, first of all you need to identify how many double bonds here, basing upon this formula only. Here is the formula: number of bonds in between the two atoms in the structures, resonance structures, by the total resonating structures. Okay, first of all, how many double bonds here? You need to see 2 double bonds plus how many single bonds here? 1 single bond only, another 1 single bond, by 3 resonance structures. Now the answer is same. We did like this, 4 by 3, nothing but 1.33. For nitrate ion also we got the answer of bond order is 1.33. Here we have the next example of sulfate ion, SO4 2-. To this sulfate ion we need to calculate the bond order. So before that you need to identify the total resonance structures of sulfate ion. Let's see now. Here is the central atom is sulfur, double bond O, here 1 double bond O, single bond O, single bond O. Okay, now you need to put the lone pair of electrons here upon the oxygen. Here 2 electrons, here 2 pairs of electrons, and here also same 2 pairs of electrons. Here already double bond is located, so only 2 electrons, 2 pair of electrons. Okay, here 2-. And next structure, sulfur, lone pair of electrons on this oxygen. Here 2 3 pair of electrons, and here 2 pairs of electrons, here again 3 pairs, here only 2 pairs. Okay, as usual 2-. The next structure is, here is the sulfur, single bond O, here single bond O, double bond O, and double bond O. If you represent the lone pair of electrons, means which are not involving in the bond, here 3 electrons, here 2, here 2, and here also 3 pairs of electrons. Okay, and 2-. And the last resonance structure of this sulfate ion, here sulfur, single bond O, double bond O, double bond O, single bond O. Okay, now the representation of lone pair of electrons, here 3, here 2, here also 2, here as usual 3 pairs, here 2-. Okay, so according to that formula, here is the formula, right? Total number of bonds in between the two atoms in all the resonance structures by total resonating structures. So you need to identify the total number of bonds here. For the bond order, calculation of bond order, double bond C here 1 2, 2 double bonds, so 2 plus 2 are the double bonds, plus 1 plus 1, these are the single bonds. By the resonance structures are 4 here, 2 plus 2 4, 5 6, 6 by 4 is 1.5. Here the bond order of this sulfate ion is 1.5. Okay, let's see the next example. If the resonance structure of CO2 resonance structure, carbon dioxide, here C single bond O, here O, like this. The total number of bonds here, so 4 bonds. By the resonance bonds, resonance structures also, for CO2 2 we need to draw, 4 by 2 2. For CO2 also the bond order here 2. In case of CO2 molecule, here we have the resonance structures. Here oxygen, double bond C, double bond O. Okay, and if you see the lone pair of electrons, here 2 pairs of electrons, here also same 2 pairs of electrons. This is structure 1 of CO2. Now another one, O, triple bond C, single bond O. Here are the pairs of electrons, 3 lone pair of electrons with negative charge. Here only 1 pair of electron with positive charge. Okay, the next structure, resonance structure, O single bond C triple bond O. Here with positive charge only 1 pair of electrons. Here 3 pairs of lone pair of electrons with negative charge. This is structure 3. This is second one. Okay, if you calculate the bond order for this according to these resonance structures, total number of bonds in between the two atoms, bond order is equal to total number of bonds means 4 by total number of resonating structures. Resonating structures are 3 here, so 1.33 is the bond order of CO2 molecule. Okay students, here in this CO2 molecule it should have 2 carbon 2 oxygen double bonds, and the normal C double bond O has a bond length of 121 picometers. However, experimentally each carbon to oxygen bond length in CO2 is found to be 115 picometers, which is in between that of C double bond O. Okay, and for suppose C triple bond O, this is 110 picometers. Hence CO2 is considered to be a resonance hybrid of these Lewis structures. Okay, it's about how to find out the resonance structures for CO2 and how to calculate the bond order also. Okay students, this is about our today's session, trick to find the bond order for molecules and ions. For suppose the molecule has resonance structure also, we identified that the formula how to find the bond order for resonance structures also. Okay, for in case of isoelectronic species also we studied that how to find out the bond order. Okay students, I think this class is very useful to you. If you like this class, if you understand this class, you can subscribe to my channel for my further updates. Thank you so much. Thanks for watching.